Hello students. In last lesson we considered PN junction diode and also how it is made. We also discussed that in P region of PN junction diode, holes are majority carriers and electrons are minority carriers, while in N region the electrons are majority carriers and holes are minority carriers. Hence, there is difference in concentration of charge carriers in the two regions, and therefore electrons from N region diffuse through the junction into P region, and holes from P region diffuse into N region. Such migration of majority charge carriers across the junction sets up electric potential difference. The N region of junction is at higher potential and P region of junction at lower potential. Hence, a potential barrier is developed at the PN junction and it opposes any further diffusion of charge carriers into the opposite regions. In the plot, the potential distribution near the junction is shown, in which VB is the barrier height. The barrier region created near the junction, where there is no free charge carriers, is called a depletion layer. The width of depletion layer is about 10 to the power minus 6 meter. At room temperature about 300 Kelvin, the value of potential barrier is about 0.3 volt for germanium and 0.7 volt for silicon. To cross the potential barrier VB, an electron or a hole requires the energy equal to E times VB. The value of potential barrier VB depends on concentration of doping impurity, nature of semiconductor, and temperature. You can see in the diagram the symbol of PN junction diode, in which one terminal is on P side called anode and the other terminal is on N side called cathode. The PN junction can be considered equivalent to a capacitor, with P and N regions as plates of a capacitor and depletion layer as the dielectric medium. But there is a basic difference between the two. On connecting the plates of a capacitor, charges flow, while in PN junction, connecting the P and N regions by wire, charges do not flow, being bound. In this situation, the junction is unbiased. Let us now understand the biasing of PN junction. There are two ways of biasing. One is forward bias and the other is reverse bias. In forward bias, positive terminal of an external battery is connected to the P side and negative terminal to the N side of the PN junction. In forward bias, the applied voltage decreases the barrier height and also the thickness of depletion layer. With increase in applied voltage, the current increases, but this increase in current is not linear. It increases slowly in the beginning and then rapidly afterwards, as shown in the IV graph, which is called IV characteristic. The variation of current with voltage is shown in the first quadrant of the plot when PN junction is forward biased. In this situation of forward bias, PN junction offers low resistance to the flow of current. In reverse bias, the positive terminal of the external battery is connected to the N side and negative terminal is connected to the P side of the PN junction. In reverse bias, the applied voltage increases the barrier height and also the thickness of the depletion layer. In reverse bias, there is no conduction across the junction due to majority carriers, and almost negligible current flows due to minority carriers in opposite directions, which is called reverse current or leakage current. It means PN junction offers a high resistance to the flow of current in reverse bias. The IV characteristic of PN junction in reverse bias is shown in the third quadrant of the graph. Let us now see a very important use of PN junction diode. A PN junction diode is used as rectifier. A rectifier is a device which converts alternating voltage and current into direct voltage and current, that is AC into DC. It is used in two ways, as half wave rectifier and as full wave rectifier. We will consider them one by one. The principle on which the diode is used as rectifier is that the PN junction offers low resistance when it is forward biased and offers very high resistance when it is reverse biased to the flow of current. See the circuit diagram of half wave rectifier in which AC to be rectified is connected to the primary P1 P2 of a step down transformer. Its secondary is S1 S2. S1 is connected to the P side of a diode D and S2 is connected to the N side through a load resistance RL. The output is taken across the load resistance RL. During half cycle of the input, when S1 is positive and S2 is negative, the PN junction is forward biased and the forward current flows through the load. During next half cycle of the input, when S1 is negative and S2 is positive, the PN junction is reverse biased and there is no flow of current through the load. This process is repeated and during one half of a cycle the current flows and in next half cycle there is no current. The output across the load is shown in the plot. This way the half wave rectification takes place when current flows only in one half of each cycle. Half wave rectifier is not of much use, so we prefer full wave rectifier. Now we see circuit diagram of a full wave rectifier. Here you can see two PN junction diodes are used. As usual, AC source is connected to the primary P1 P2 of a step down transformer. P sides of two diodes D1 and D2 are connected to S1 and S2 respectively, and their N sides are connected to the middle point of the secondary through a load resistance RL. During half cycle of the input signal, when the first diode D1 is forward biased and the second diode D2 is reverse biased, the forward current flows through the load due to flow of majority charge carriers of the first diode. During next half cycle of the input, the first diode D1 is reverse biased and the second diode D2 is forward biased. Hence the forward current flows through the load due to flow of majority charge carriers of the diode D2. As a result, current through the load RL is in the same direction during both half cycles of the input. We get a unidirectional output having ripples, which means it has both the components AC and DC. The AC component is filtered by a filter circuit and the output DC is made steady. For filter, a capacitor of high capacitance is connected across the output of the rectifier and hence steady DC output is obtained across the load. So we see how useful a semiconductor becomes in the form of PN junction diode. There are some more uses of diode. We will talk about them later. See you then.